This is your last section of notes for this chapter. My goal is to get this in under 30 minutes because I know that a lot of these videos have been long. So what we're going to do is we're kind of going to use the information that you've learned so far and kind of apply it to water navigation. So this would be helpful if you're thinking about any type of career that would involve traveling on the water, which in Indiana I can't imagine that you would be. But anyway, so we're going to use bearings, and there's water navigation and air navigation. This part of your notes explains air navigation. I'm kind of going to ignore that because your homework really covers water navigation. So these are the ones I'm going to go over with you. When you see a bearing, it's going to look like this. At least the ones in pre-cal are going to look like this. These are the way your problems are going to be set up. You're going to first be given either a north or south direction. So that kind of tells you which way to look toward. So this one says, first of all, look toward the south, okay? And then it says, look 35 degrees. So turn your head 35 degrees toward the east. Look south first, turn 35 degrees toward the east. This angle is 35 degrees. So when we're doing bearings, here's the thing. All of our angles with bearings are going to be with our y-axis. Let's do another one. See this one? This says look north first. Look north first. Then turn your head 80 degrees toward the west. This angle is 80 degrees. This bearing, the angle is made with the y-axis. This worries me because all of the reference angles, so for the past like 5 weeks, I guess, 4 or 5 weeks, we've been looking at this angle with the x-axis. And now all of a sudden with bearings, oh hey, you're looking at the angle with the y-axis. You got to keep that straight in your head. North, 45 degrees east. Look north, look 45 degrees toward the east. This would be 45. Well, this one would be too, because together they make 90, but whatever. Okay? We're going to practice on some, and then we're going to pretend that we're going to hop in a boat and take a little trip. Alrighty. So, first of all, it says, how do you get from O, the origin, to D? Give me the bearing that would get me there. Starting here, how do I get here? Well, first you're going to tell me to look south. First, you're going to tell me to look south. Then you're going to tell me to turn my head 25 degrees toward the east. 25 degrees toward the east. There you go. O to A. O to A. First, you're going to tell me to look north. Then you're going to say, turn your head that much. Do the math. Figure it out. So if that's 20, the whole thing is 90. You're going to have to turn your head 70 degrees toward the east. O to C. You're going to tell me to look south first, and then I'm going to turn my head a very small amount. Do the math. Figure it out. If that's 75, this would have to be 15. So it's going to be south, 15 degrees toward the west. And the last one, O to N. O to N. If you go directly along an axis, you would just say due north. Alrighty, let's do some trig. So pretend that boat leaves the entrance. Okay. We're going to pretend that we're in a boat, and it's going to leave the entrance to a harbor. So the origination of the boat, this is going to be our origin. Okay? And we want to send it on a course that's 40 miles long and on this bearing. So we're going to draw a picture, and we're going to need to look south, and we're going to need to look 64 degrees toward the east. So I'm thinking we need largely quadrant 3. Most of what we need is going to be quadrant 3. right? And here's the origin. This is where we're starting. So we're going to look south. We're going to turn our head an angle of 64 degrees. We're going to start our boat and head that direction. Boat. 64 degrees. See where I put my angle? And the distance that we went, I don't know how to say that in water, is 40 miles. Okay, now here's the thing. What if this was us and like your family or something, and you were out here on a boat and all of a sudden your boat started taking on water? You're like, oh crap, we need help. So somebody back at the harbor, back at the marina, wherever we started from, somebody's going to need to come out here and rescue you. Well, you need to tell them where to go. So you would say go, on a bearing of 64 degrees and go 40 miles this way. If they took the long way, which we hope that they wouldn't, but it's asking how many miles south. So if they took the long way and went here first, and then turned and went here to reach us, find those two distances. I'm going to call one of them X, and I'm going to call the other one Y. Find those two distances. Just kidding. If they were going to come rescue us, they would come straight there. But this is what it's asking, how far south and how far east. So, this is just a simple trick. Look at your angle. You've got opposite, you've got adjacent, you've got hypotenuse. So I set up equations to help us find. There we go. I went sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. I cross multiplied. Wow. And then use my calculator. Thought I was going to save some time. I don't know that I did or not. X is approximately 35.95 miles east and about 17.53 miles south when I solved each of those two equations. Feel free to pause and copy that down. Next problem. Again, the boat leaves the entrance to the harbor, so that's going to be our origin. Also, I put a little, I don't think this is in there, but in the second line it says we're going to turn the boat clockwise. You need this information. We're going to turn 90 degrees clockwise, but I'll explain that when we get there. So, we're going to go on a bearing north, 42 degrees east. I think I want quadrant 1 for this one. This is going to be in quadrant 1. Here's the origin. Ready? Here's the origin. We're going to go north, turn 42 degrees toward the east. Go. This is the angle you should label 42 degrees. Okay, now we're here. $42. Oh, and we went 25 miles. You better label that. 25. Now, we're here. The captain, that's me. The captain turns the boat 90 degrees clockwise. So imagine this, ready? I am on this path. I am traveling. I cut my engines. I may have dropped anchor, I don't know, whatever. And I pretend I've come to a stop. Now ready? I'm going to turn on my turn signal to turn right because I'm turning clockwise. I'm turning an angle of 90 degrees, and then I'm going to start up my engines and take off. Do you see how I tried to make that a 90-degree angle? Because I turned an angle of 90, which would make that one 90 as well. I turned an angle of 90, which would make that one 90 as well. And then I went 18 miles. And this bearing is not important in this problem. It already gave you the turning angle. I could have made it a lot harder, but I didn't. And then we stopped. Here we are. Okay, so we went 25 miles on this bearing. We turned 90 degrees clockwise, the same as a clock goes. We went 18 miles. Now, what if we were here and taking on water? Would you want someone coming from the marina to take the same path you did to rescue you, or would you want them to come straight there? You would want them to come straight there. So I'm going to draw a path from the marina, or whatever it's called, to us. And I'm going to call that A. And then I've already got A up here. How far is the boat from the harbor? So if the direct path, how far is it? I just used Pythagorean theorem. Now, what are you going to tell the guy that's coming to rescue you? You're going to say, go north, a bearing of 42 degrees east. Nope, that's going to put him out here. You want him to go more than 42 degrees. How much more? What's this angle? Let's find it. Let's find this angle right here. Now, I'm not going to use A because A turned out to be around a decimal. I think I'm just going to use the 25 and the 18. So according to this angle, this is adjacent, this is opposite. I think I'm going to use those two. So I'm going to go tangent of the angle that I don't know is opposite over adjacent. So on my calculator, I do tangent inverse fraction equals, and it's going to give me an angle, 35.8. That's theta. That's not the bearing. That's theta. So the guy that's going to come rescue you, you say, go north, turn 42 degrees plus 35.8 degrees, and then come get us. It's going to be 30.8 miles. So we're going to go 42 and 35.8 makes a bearing of north, 77.8 degrees east. That's the bearing. That's the distance. Alrighty. This last one's kind of tough. We're going to go due west, and then we're going to change course to kind of go north a little bit and more west. So I think I need quadrant 2 for this. Can you kind of picture that? We're going to go west, and then we're going to go northwest. So we're going to need quadrant 2. All right, here we go. And this is the origin. This is where we're going to start. Ship leaves, heads due west. That's this. Due west, at 20 nautical miles. Okay, don't freak out about the units. Just if you want to just think of it as miles, whatever, that's fine. 20 miles per hour. 20 miles per hour. It's just a rate. So at noon, they head this way. So at 1 o'clock, they had gone 20 miles. At 2 o'clock, they had gone 20 more miles. So I'm going to say that by 2 o'clock, the boat was like here, right? You okay with that? 1 o'clock, 20 miles per hour. 2 o'clock, 20 miles per hour. That makes a total of 40 miles. Then, this is going to be tricky. Then the ship changes course with a new bearing. I need to kind of make a new origin. The ship changes course with a new bearing. I need to make a new origin, kind of lightly colored. Here I go. New origin. Okay. From here, let's mark off north 54 degrees toward the west. Now, this angle is 54. This one's not, but you can figure out what it is. You want to? Go ahead, write it in. 54, 90, 40, 30, 36. Okay, 36. So here we are. Oh, I'm right at the edge of the paper. Here we are. Oh shoot, we're taking on water. Find the ship's bearing and distance from the port of departure. Oh, hang on. At 3 o'clock. Wait, we were at 2 o'clock. What just happened? So 1 o'clock, 2 o'clock, 3 o'clock, that means that we went 20 miles, right? From noon to 1, 20 miles an hour. From 1 to 2, another 20 miles an hour. From 2 to 3, 20. Okay, so that was 20. Label this with 20. Somebody at the original harbor needs to come and get us. We need to find that. So I'm going to color that red. We need to find that. We need to say 2 things. We need to tell the guy that's going to come rescue us what bearing to take and how far to go before he rescues us. Okay, slight problem. See the red and the black segments that form a triangle? It's not a right triangle. Slight problem. Sine, cosine, and tangent don't work unless you have a right triangle. Slight problem. It's okay. We can make a right triangle. Ready? Let's see. I'll highlight it in blue. Gosh, can you see that? Maybe I'll make it a little wider. Oh, there we go. See that? That's a big right triangle. If I knew this leg and this leg, I could find the red hypotenuse. I don't know those. I know this part, but I don't know this part. But I think I could find this part, don't you think? I think I could use the fact that, so I want the whole big leg right there. I don't know that. I know this. But I also have a smaller right triangle. See the smaller right triangle? The big right triangle I outlined in blue. The smaller right triangle, I know this angle and I know the hypotenuse. I think using trig, I can come up with this little leg and this little leg. So I think I'll call the bottom leg X. I think I'll call the vertical leg Y. Does that sound good? Now, let's use trig to find them. So I'm going to go cosine 36 equals x over 20. X is approximately 16.1803. You might want to store that. You might want to store that in your calculator. Now let's work on finding y. 36 and y and 20. Sine 36 equals opposite over hypotenuse. Y is approximately 11.7557. You might want to store that in your calculator. Oh, no, hang on. Yeah, that's right. Okay. So, red segment. Ready? Red squared equals the whole thing, the 40 plus the x squared, plus this squared. The red segment let me get rid of this so I can have some writing space. The red segment squared equals 40 plus the 16-ish plus the y one. So when I did that math, I got approximately 57.4 miles. Okay, so that's the distance we need to tell them to go. Now we need to tell them the bearing. So we need to tell them, point your boat north, turn, I don't know, toward the west. We need this angle. Well, shoot, this angle's not even in a triangle, but this one is. Let's focus on this one. I think I'm going to call it theta. I think I'm going to make it purple. I'll make it purple, and I'll call it theta. So, in the big triangle, we have theta. This huge long leg is like 40 plus something. That's the adjacent side. The opposite side is y. And the hypotenuse is the red one. Hopefully you've got all those stored. Hopefully you've got the y value stored and the red one stored. Those are the ones I'm going to use. So I would go opposite. I would go sine of theta equals my y value, which was approximately 11.7557 whatever, over my hypotenuse, which was 57.4 something. Turns out, if you do sine inverse, theta is going to be about 11.8 degrees. Okay, that's not the one we want. That's this one. So take it away from 90. 90 minus 11.8-ish. I'm going to say go north 78.2 degrees west. That's the bearing. I'm going to tell our rescuers, point your boat north 78.2 degrees toward the west. Start your path and go for 57 miles. And you'll be able to rescue us. Alrighty. Good luck with those. Make your pictures good. Make your angles with your y-axis. Good luck.